Hello and welcome to another LeetCode problem. Today we're going to be doing LeetCode number 200, number of islands. It's a pretty straightforward problem, but I just wanted to show you with this problem how to make a standard template of a common algorithm you're going to use. And so in this problem, you're given an n by n binary matrix, and it represents a map of ones and zeros, and you want to return the number of islands. So an island is surrounded by water and is formed by connecting adjacent lands horizontally and vertically. And you may assume all four edges of the grid are surrounded by water. So let's just take a look at this example one here. So in this example one, we have 1, 1, 1, 1, 0. We have 1, 1, 0, 1, 0. Then we have 1, 1, 0, 0, 0. Okay, and so in this example, and then we do have one more actually, so we have this. So just by looking at it, if you think like all connected ones are an island, it's pretty easy to see what an island would be, right? So this whole thing, you can just draw out the whole border is an island, right? Like this whole thing is an island here. And so this whole thing would be connected. So this whole thing would be one island, and we would want to return 1. And for the second example, I'm not actually going to draw it, but you can see this left thing is an island, this middle thing is an island, this right thing is an island. So we want to return 3. Okay, now let's think how we would do this. So it's going to be pretty straightforward. There's two ways you could do it. And for these kinds of island problems, what you really want to do is you want to iterate through every single value. Usually you want to iterate through every single value in the matrix. And then in this case, what we can actually do is, like, let's say we get to a 1, so we get to a 1 here. All we have to do is we can just DFS from every single one in the island. And then we can actually turn, like, every island we can go to, we can do one of two things. We can either have a visited set where we put every single island into it, or we can actually just change the numbers like in place, and then that way we're not gonna like run into them again. So what we're actually gonna do is we're gonna actually, every island we run into, we'll just change every number we run into in the DFS to a 2 instead. So what that's gonna look like is, like, we'll start with this, and then we can DFS, and then everything we DFS to will change to a 2. So this will all change to 2s, like this. And then we're gonna have, so every time we do see a 1, we're gonna add 1 to our result. So now our result's gonna add 1, and then we're gonna go through the rest of this whole array, and we're gonna, for every other 1 we find, we're gonna add 1 to the result, and then we're gonna change all the ones that it's next to 2s. And what that's gonna make sure happens is, we're gonna, every time we find a 1, that's a new island. So for example, let's do this other last example here. So it's 1, 1, 0, 0, 0, 1, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 1. Okay, so in this example, we'd get to this 1, then we would DFS to every single island next to it. So that'd be this, or every single one next to it. So that's one island. Now we would keep going, then we would hit this 1. We'd change that to a 2. Then we'd hit this 2, and we'd change all these. And so we would hit 3 ones. We'd hit this one, and this one over here. So our result would be 3 here. And so I just kind of want to show you this problem for the standard template of the DFS that you're going to want to be using. And I'll go over everything here. And if you just like lay out all your DFSs like this, it's going to make it a lot easier for you to write a DFS so that you can do it multiple times and you'll be used to it. Okay, so the first thing you're going to want is you're going to want a directions. You're going to want a directions array. And the reason is because you're going to be changing your row and your column. You're going to be going up, right, left, down. And so if you have a directions array, that's going to make it really easy to do that. And I'll show you how. And so for directions, it's pretty simple. We're going to have 4 directions. So up will be symbolized by 1, 0. Then we're going to have a down symbolized by -1, 0. And then we're going to have our right. So 0, 1. And finally 0, -1 for a left. So we have these directions. Now the other thing you generally want to do is you actually want to make variables for your rows and your columns, which you could do like this, equals length grid, and then length grid 0. So you're going to want that. Now, you can either have a visited set, but in our case, we're going to change our numbers in place, so we don't need anything there. And so, but if you did have a visited set, you can have a visited set as well here. And so these are the things you're going to want for pretty much every single DFS when you have these grids, and they're going to make it a lot more helpful and really clean to write out your outputs. Okay, now let's actually make a DFS function. That's the next thing you want to do. So you want to have this directions, this rows, columns, then you have a DFS function, and then you actually have your loop looping through everything. So for our DFS function, it's going to be, once again, kind of following a template. And so it's going to have a row and a column. And you can check for out of bounds in either the DFS, or you can check for out of bounds in the actual for loop. I'm going to do it in the DFS in this case. And so I'm going to write all the values that I don't care about in this DFS. So all these values that will return, we can just straight away return. And so out of bounds means if your row value is less than 0, right? If you're out of bounds to the left, or your row value is greater than or equal to rows, which means it's out of bounds. So that would be one thing, right? So if rows is less than 0 or rows is greater than or equal to rows, that means the row is out of bounds. Now for the columns, it's the same thing. So if column is less than 0, right? If column is less than 0 or column is greater than or equal to columns, you are also out of bounds. And then usually you have one more case, and that case is you usually want like a particular value you're looking for. So in our case, we're looking for 1s. So we can say if the value that we found is not a 1, we don't care. And so that's going to be grid row column. It's a little long, but it's okay. Okay. So these are all the things that are like that we don't care about, and you do want to check for these out of bounds before you do this, because otherwise this will be out of bounds, and then that will give you an error. So usually in your first statement you say like, what are the values I don't care about, and if it's these values you can just return straight away and do nothing. Now you know that you have a value that you care about, so you know that you have a 1 in here. And so now you can actually do your DFS. And in your DFS, in the first part, what you're going to want to do is you're going to want to do something to the value or add it to the visited set, or whatever the problem asks. So in our case, we actually want to change our 1 to a 2. And so let's do that. So we're going to write grid row column equals 2. Okay, now the next part of the standard template of the DFS, what you're going to want to do actually is you're going to want to loop through these directions, because usually in a DFS you're going to want to try to go up, down, left, right. And so you're going to want to loop through these directions, and we can actually do it like this. And I'll show you why this is like cleaner. Now we can actually get these new directions really easily. So we can just say a direction, and I usually use nrow, ncall, things like that, right? So, and now we can literally just say row plus directions, or it's going to be direction 0, and call plus direction 1. And what that's going to allow us to do is, like, we have a row and a column. We're going to loop through these directions. The row is going to be the 0 indexed element in whatever we're currently in, and then the column is going to be the 1 indexed element in the direction we're in. So we're going to loop through these directions. Like this will be the first one. So we'll say row plus 1, column plus 0, and then we're going to use our default values here to find the new row in the column. And so this makes it much cleaner if you do have this directions array, and that's the other thing. For these rows and columns, you're going to use it a lot of times in your code. So it's better to make variables for them, so you don't have to write length grid like 10 times. And it also makes it a lot more legible. Okay. And so now that we have this, now it's pretty straightforward. All we're going to have to do is we're going to have to call DFS on it, right? So we can just do DFS on nrow and call. Okay. And now we're going to call DFS. And then we don't have to do anything else, so then we can just be done in this case. But like I said, this is a simple problem just to show you a template. There will be tougher problems where you do have to like get these values and do something or things like that. Okay, so now that we wrote the DFS, the last part of the standard DFS template of iterating over these things is a nested for loop, because you are generally going to have to loop through every single thing in here. There will be some small changes, but for the most part, that's what you got to do. And so once again, we can do it pretty simply because we have these values so that it looks nice and clean. So column in range columns. Okay, so now remember, what are we doing? All we're doing is we can actually pass DFS for every value because the DFS is doing our error checking for us, right? And so we do want one more thing, and this is particular to like this problem, but this is not what you're going to generally want. So here you are going to want a result, and then you are going to want to update that result. But that's not always the case, right? So in this, you do have this result, and we're updating here. You could update it here as well. Also, what you could do is you could have the check in here. I guess that would make it, then we don't have to use this non-local thing, right? So we could do that. So we could say if grid, so we don't even have to pass these things into the DFS, even though the DFS will handle it, but that's okay. So if grid row column, we don't need these, equals 1, then we can update our result and call DFS. Okay, and our DFS will handle the rest of it. So we still do need this check because this DFS will try to go to the other column, like the other rows and columns. So you could have the check here, you could have the check here. There's a bunch of places you could do it, but I like to do it this way. Honestly, depends on the problem. Sometimes it'll be easier to write it in one or the other. But these are pretty much the standard things you need. So you need directions. You want to make this row and columns. You want to make your standard DFS with a check somewhere where if you're out of bounds or if your value is incorrect. And then you do this direction and directions thing where you call DFS in every direction. And then finally, you do have this nested for loop where you have some conditions. Okay? And so now, what we need to do is we need to actually return res, I think. And hopefully I didn't screw anything up. Looks like we did. Output 0, expected 1. So let's take a look. Oh, these are strings. Okay, so these are strings. So then what we need to do is we need to say this. So it does not equal 1, and then we'll make the string 2 instead. And yeah. So we need to actually also, let's see, so this is row, this is row. Okay, let's see if we have anything else. Direction, this is directions. It's been a tough day. Okay, and so that works. So let's think about the time and space complexity. So generally, if you have a DFS that's not too fancy, like the problem isn't too hard, generally your time and space is always going to be pretty similar. And so here, you're always going to have to go through the grid, but because we have a DFS, if we go to a value that we've already seen, we're just returning straight away, so we're not really doing anything. So you don't have to count that as like visiting it again. It's going to be the same thing. And so this is going to be m by n, and pretty much all your DFSs are going to be m by n, assuming you don't have to visit things more than once in this kind of grid. And then space is going to be, so if you're actually overriding the input, it's going to be O of 1. But if you have a visited set, it's going to be O of m by n as well, because the visited set can have every single one of these indices. So that's going to be one or the other, and this is pretty much going to be the standard space and time for your standard DFS in a two-dimensional grid. It's either going to be that or it's going to be this. In our case, it's O of 1 because we used because we overrid the input. But if they don't want you to override their input, instead of doing this, you can just have a visited set, and you can just, instead of checking, instead of you'd probably have to add another check and make sure your number isn't in the visited set, so you're not revisiting over and over. But I just wanted to show you guys a standard template for DFS. It's going to be quite useful, and if you just code up all your DFS questions like this, I think it's very good to. And I did watch like another. I actually watched a video where like a super good competitive programmer was explaining his thought process about this stuff, and he just said like, if you have a standard template for all these algorithms, try to stick to it, because it's just going to make the other work really easy. Like, like here's my standard template, and what are the little things I need to change? It's gonna make it so you have to worry about less things, and you can code much faster, right? You don't have to think about like, what do I write? You just write the same thing over and over and over for the simple parts, and then you just fill in like the 3 or 4 lines of code that are different for each of your functions. So hopefully that was helpful for you, and if you like the video, please like the video and also subscribe to the channel, and I'll see you in the next one. Thanks for watching.